Hello, beautiful people. Future me. Welcome to another programming workout of mine. And we will start with 5 minutes of typing as always, and then we will continue on execute program. So let's get into it. Oh, come on. is the result. 3%, that's not bad. Okay, so we will close this and we will continue in the types execute program thingy. So kill this and start the time. Const user name Amir, symbol to string Amir. So those are two, but the stringify will ignore the symbols. So after doing the round, we will get this thing. We have a user constructor name, then we have a get. Okay, and Amir user Amir. Okay, so this will return name Amir, like so. Define convertible class with myString and my. Oh, I remember. This is the one which will do the toString method basically. And so class with myString tag and myString which work the same way as symbol toString tag and toString. Your class should have myString method that does the same thing as toString. That method should access the myString tag symbol property on this, so that objects can customize their own myString behavior without redefining myString itself. Okay, so default should be object. So you need to provide a default implementation of myString tag that returns object. Da -da -da, da -da 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 -da. So I will have a convertible. Here, I think I need a construct. Okay, so first of all, this will be symbol and will be my. It doesn't matter what it says here, right? So I'll say something like so. Okay, now he will have a constructor, and that will do what? That will do nothing for the time being. And then we will have the myString thing. But we have this name. Okay, so we can have getter string tag, and that will return object. Close it. With myString tag. And myString. Okay, so the myString should be okay, I have that and my my string. My string, it will take nothing and it will output. Turn, and here will be the ligature, the string ligature. How is it called? Maybe ligature. And I will return what object space, then we will have this guy, that will be this dot string tag, I think. Close that, and then this guy. Oh, and I forgot the closing bracket without a space. Okay, so what do we have? Convertible my string, so the plain string should return object, then what? Amir is user my string. I'm not sure. Maybe it is. Unexpected token where damn it. Here's code problem for the complete. Oh, convertible again? My string tag and my string, which work in the same way as the symbol to string tag and do string. Should access the my string tag symbol property on this. So that objects can customize their own my string behavior without redefining my string itself. The default output should be object. That's the exactly same thing, right? Remember that you can never access symbol key using. That's the same thing. Okay, where is it? 8. What's wrong? Oh, it is without the dot. I forgot. So this will be simple like this. Here will be constructor like this. Then I will have getter get my string tag like so, and that will return object like this. Then we will have my string method that will return string, and we will construct it from here, and it will say this object space dollar open this without dot, and we'll say my string tag. Why there shouldn't be a dot? I don't get it. Close that, and close this, and close my string. Class is closed. Oh, whoa, cool. Cool. Oh, defining iterators and other stuff. Let's go. I wanted the other one. Well, never mind. JavaScript object keys must be strings, numbers, or symbols. A string, a number, a symbol, keys. Not. Yeah, well. This is computed thing. Okay, so this will be a string one, a number 2, a symbol 3. If we try to use any other value as a key, that value will be converted into a string. Okay, so we have an object, undefined. I see, so undefined was converted to string. And that was array, so that array was converted to a string. Suppose that we want to build a map of train roads. Which cities are connected by trains? There are some European train roads connecting different cities. London, Antwerp. Okay, sure. If we represent the cities as strings, then we can track connections with a regular JavaScript object. The keys are city names, and the values are arrays of cities that connect directly to the key city. Okay, so London will have a Lille will have a London, Brussels, Paris, and Antwerp will have Brussels. Okay. Makes sense. Okay, so this is connections. Lille includes Paris, true. Antwerp includes Brussels, that is false. All connections are bidirectional. For example, Brussels connects to Lille and Antwerp, so both of those cities also connect back to Brussels. This scheme works very well, as long as we represent cities as strings. Now let's complicate things. We want to store additional information about the cities, like their populations, we'll have to make them objects. Sure. We can use computed property syntax to use those city object as a key in our connections object. Interesting. This code looks reasonable. This is a little bit confusing because on the first side I would think this is an array with one, well, without knowing better, and this is actually a computed property. This code looks reasonable. In most other programming languages it would work, but in JavaScript it fails in a very confusing way. Let's ask it which cities Lil connects to. Confusing way, let's ask in which cities Lil connects to. The answer should be London, Paris, and Brussels. Yep. Connections. And it takes Brussels. What? That's wrong. Our connections objects is a regular JavaScript object, so its keys must be strings, numbers, or symbols. When we use a city object as a key, it's automatically converted into a string. Via its toString method, but the default toString method always returns object. All 5 cities are converted into that string, so the object only has that one string as a key. Ah, okay. So we are rewriting that thing like 4 times. It's set to that, then that, and that. I see. Cities, London, toString, yeah. Okay. Object, I see. When we try to look up any city object's connection, the city gets converted into the string. Object again. We get the same answer no matter which city we ask for. Yep, got it. This explains why every city thinks that it's only connected to Brussels. The last key in the object definition was cities and verb. Yeah, I got it. This is a big problem. It significantly limits our ability to model complex relationships between data. Fortunately, JavaScript has a solution, the map data type, which we'll see in another lesson coming up soon. Let me finish the lesson. Defining iterators. We've seen for of loops. Yes, we did. So times 2 push, so it will be 2, 4, 6. We've also seen for of loops looping over strings, where the loop iterates over each character in the string. ABC, uppercase, that is array, so it will be A, B, and can see like this. At a glance, it seems like for of loops have specific knowledge about arrays and strings, but they don't. Instead, JavaScript defines a more general way to access the elements of data type in a particular order. Arrays, strings, and some other data types are iterables. Loops and other constructs can iterate over them. Iterate means perform repeatedly. There are rules about how iteration works. The thing being iterated over, like an array string or a custom object that we define, exposes certain methods, then certain methods exposes certain methods, array string custom object that we define exposes certain methods, then the thing doing the iteration, like a for of loop, calls those methods. As long as both sides agree on what the methods are, the iteration works. Is that the generator function? Suppose that we want to iterate over an array called letters. We'll break the process down step by step, with each code example building on the previous one. First we get an iterator from the letters array by calling the symbol iterator method. Okay, so we get the iterator, letters, symbol iterator, okay. And that is a function, okay. The iterator object, return something, okay. The iterator object has a next method. Calling that will give us one element of the array. The element is wrapped up in an object that provides both the element value and a done flag to tell us whether there's more data remaining. Next, okay, so done false, value a. Each call to the next method returns the next value from the original array. Last time is a, then it's b, then it's c, sure. So b, and here will be done, it will be true, I believe. True value will be c. It's not? Okay. Huh, okay. Now we've iterated all three of the letters. If we go next, done will be true and value will be undefined. Okay, done. True value find. Our iteration is finished. We've got A, B, and C. To summarize the whole process in English, get an iterator by calling letters the object symbol iterator. Call the iterator's next method repeatedly. When next that done is true, stop and throw the iterator away. Now that we know how iteration works, we can define our own iterable object and our own iterator. We need to provide a method next that returns an object with keys, value, and done. This one iterates over all numbers below 3. At the end of this example, we loop over our own object with a for of loop, and it works. So will I continue or not? Numbers below 3. Symbol iterator. Return new number iterator. And the number iterator is class. Constructor this value equals 0. Okay. Next, if this value is smaller than 3, we value a new value, then this value will increase. We'll return that value we've got. We will return object, and that will consist value, and then you can say just value. Oh yeah, that was the shorthand in modern JavaScript. Else, yeah, so this will return 1, 2, 3 in array. So it will be, well, the entire thing. 1, 2, 3 in array. Oh, 0, 1. It will start at 0. 0, 1, 2, and 3, like so. Okay, now I'm kind of guessing. How come? Yeah, because if it's 3, it will return undefined. Man, I'm tired. Classes are never necessary in JavaScript, so let's repeat the above example without using them. We can define the iterable as a literal object with a symbol.iterator shorthand method. Instead of a number iterator class, we can define makeIterator function that returns new iterator object. So we have a function makeIterator. Symbol iterator will be makeIterator. Okay, so current value that, and return. It will have next thing in it. Okay, and next we'll have the current value. Current value increase. This part is the same. So they defined the function in here, which is returned. Well, it is an object with that function. Okay. Oh, this will do the same thing. And that will be 0, 1, 2. Like so. The class approach and the object approach are both fine. In some situations, one will be a better submatch than the other. But in many cases, it's a matter of preference of choosing what you are more familiar with. Or if you are updating existing code, it's probably best to work within the existing design, whether it's class-based or object-based. The examples above both seem like a lot of code for what they do. It's true. We should shorten the code somewhat, but writing iterators manually is always a bit verbose. A future lesson will cover generators, which replace the wordy examples above with a three-line function. But for now, we are focusing on iterators themselves. So we have to deal with the full complexity. Okay, so this is iterator. We could use the generator as well. I know how to write a generator. You showed me already, I think. So far, we've avoided some confusing terminology around iterators, but now we'll mention it briefly because it does come up in practice. The entire process of iterating is governed by the two iteration protocols. Protocol 1 is the iterable protocol. That means that an object has symbol iterator method. Arrays, strings, and our custom objects above follow the iterable protocol. Protocol 2 is the iteration protocol. That means that an object has a next method, which in turn returns object value done, or number iterator class, and the object returned make iterator function. Both follow this iterational protocol, so the iterators that we get by doing some iterator. Yep. We can think of a for loop in terms of the two protocols. It uses the iterable protocol to get a fresh iterator. It uses the iterator protocol to consume that iterator. It discards the iterator because it's now used up. These terms are confusingly similar. The iterable protocol and iterator protocol combine to make up the iteration protocols. You'll probably mix them up. We definitely mix them up. Oh, iterable protocol and iterator protocol. I missed that one. I even missed that there's a difference. So iterable protocol is that it returns an iteration protocol. I think I might remember it. We'll see. The iterable protocol and iterator protocol combine to make up the iterations protocols. You'll probably mix them up. We definitely mix them up. They are only correct in this lesson because we checked and rechecked the docs many times. This is fine. The important part is how they work, not what they are called. The docs. I'll look at it later. And we finish. Okay. So I did JavaScript and we are 9 minutes over. So that means we are done. Done is better than perfect. And I will see you next time.